Hey there, and welcome to your supplementary lecture video on 7.1 air pollution. Let's go ahead and get started. So, as always, begin with the end in mind. You can see all of the things that you need to know about here. Which is the air pollution that specifically comes from coal, what comes from fossil fuels. Now, we may not touch on all of that in this particular video, but we will get to it through the series. How air quality is affected, and there is a law that you specifically need to know, and then be able to differentiate between primary and secondary pollutants. All right, so the big picture here is that there is no way. Air pollution that occurs in one place can affect other places. And it's not just the environment, it's also human systems like buildings, and then also the human respiratory system. Please make a note that air pollution occurs in the troposphere. It is not a stratosphere thing, it is a troposphere. So what you should immediately think about when you hear that is that air pollution can be moved around by wind, and then it can also be taken out of the air by rain, and wind can also lower the concentration of it. But remember, again, there is no way. If it's not in the air, if the rain comes, that means it is now in water that can end up running off to other places. Okay, so here are all different places that you can get pollution. Please notice on the far left of this slide, you do have natural sources of pollution. Please be aware of what those sources are and what type of pollution is released by it. Clean Air Act, just be aware that it sets specific standards for what does it mean to have quote-unquote clean air in the United States. There are 6 specific criteria pollutants, which are the 6 things that this law focuses on, but then there are hundreds of other minor things that it keeps track of. And do also realize that this is a law that will fine organizations that can be proven to be breaking the Clean Air Act. Okay, so the 6 outdoor, what are called quote-unquote criteria pollutants, the ones that we focus on altogether, are known as the NAAQS, the National Ambient Air Quality Standards. You can remember that via nose clip. Nitrogen oxides, which are the NOx of it all. Ozone, sulfur dioxide, carbon monoxide, lead. They specifically look for lead, but we're also talking about things like mercury and cadmium and arsenic, and then particulate matter. You need to know chemical formulas for these. Are they primary or secondary pollutants? Where do they come from, and what is their effect on the environment and on human health? Okay, so again, these are the 6 criteria pollutants that we focus on. There are the formulas that you need to know. Remember, nitrogen oxides are NO and NO2. Collectively, it's called NOx. Where do these things come from? Largely from the combustion of gasoline in motor vehicles. Now, where do they come from naturally? Forest fires, remember, are part of the nitrogen cycle. Lightning can cause a reaction between atmospheric nitrogen and atmospheric oxygen in the air. And then what does NOx do? Remember, air pollution is always going to be a respiratory irritant. Please do not make the mistake of thinking that everything causes cancer. That's not the case. Stick with respiratory irritant. Stick with, for the most part, stick with exacerbates previous conditions, like it makes asthma worse, emphysema worse, any sort of pneumonia worse, any sort of pre-existing condition. Acid rain and photochemical smog are secondary pollutants that we'll be talking about in other videos. Okay, ozone. you need to realize that ozone is good up high and bad nearby. When it is in the troposphere, that is not where it needs to be. It is a secondary pollutant there. It has some specific effects on things, but then it's also a greenhouse gas, which we will talk about in subsequent videos. It also damages plants. So here's how you can differentiate between the two. Notice they're the same molecule, it just depends on where it is. So please keep that in mind. You need to know how ozone forms, and then in both the troposphere and the stratosphere. Okay, in the stratosphere, ozone is split by sunlight, oxygen is split by sunlight. One of those oxygens they don't like hanging out by themselves, so it binds with another O2 to create that O3. In the troposphere, this is a series of not a series of events, but an event that is called photochemical smog, which we will address in another video. I just wanted you to kind of see that here. Notice that it has to be in the presence of sunlight and then also heat. Again, NOx comes from the burning of fossil fuels, and then VOX, which is volatile organic compounds. We'll talk about that more in a minute. That is anything that really has an odor. All right, so what are some issues with good ozone? This is something from subsequent, from units that won't technically be tested on the national exam, but I'm bringing it up here in case it does somehow tangentially help you with your understanding of a question. Okay, ozone in the stratosphere was depleted by what are called CFCs, which are chlorofluorocarbons. These were the chemical that were made to create something called Freon, which is a refrigerant that helps your refrigerators do what they do. It was also a propellant in everything from hairspray to paint. Through something we're going to talk about later, they were banned. The aerosols don't contain this stuff anymore, and shocking no one, the hole that was chewed into our ozone, or the thinning of the ozone, has largely repaired itself because we stopped making the things that chewed it up in the first place. We will talk about specifically how that happens right here. Okay, so again, this is technically part of Unit 9, I think, but I'm still going over it here just to kind of make sure that in case you're asked about that, like in case it comes up as a side topic, you kind of know what's going on. So you do need to know about this for your Unit 7 test. I don't care that you know that it's Roland and Molina who discovered what CFCs were doing to the stratospheric ozone. I do care that you need to know how it is that CFCs chew up ozone, and it's super simple. It's a gas, it rises, it hits the stratosphere, a chlorine pops off. The chlorine collides with an ozone, breaks off the O2, carries that oxygen with it until it hits another free oxygen, creating more O2, and then, this is the key part, that chlorine continues to ping-pong through the stratosphere to continue chewing up ozone. So it doesn't take much of this to cause problems. It could stay in the stratospheric ozone for decades, if not a century or two, before it finally rises into the upper layers of the atmosphere. And then what's even worse about this is in the troposphere, it does act as a very potent greenhouse gas, which we will also talk about. Do also realize, I won't ask you about this, but there is something called the Montreal Protocol that did ban the manufacture of this globally. And again, since that ban, we have seen the ozone layer basically repair itself through natural processes. This is a great example of how the world can work together to fix something that we screwed up in the first place. So again, what I do expect for you to know for this upcoming test is that this process here. What is a chlorofluorocarbon? What is the active part of that? You can see right here that you have a carbon in the middle, you have 3 chlorines and 1, that's a fluorine right there. But it is that little chlorine that pops off in the presence of UV light that makes this process possible. Okay, so what happens if we don't have this stuff? Increase in skin cancer. It's super, super easy. You also can have skin ailments in general, disturbs life cycles of plants, destruction of marine life just because they don't have a lot of protection from that increased UV light. That also means that things like amphibians can end up with skin ailments that kill them. And then also UV light causes cataracts, so it can lead to blindness. Why is ozone a bad idea, or how does it form in the stratosphere? So you have NOx is released usually by motor vehicles, and it interacts with FOx in the presence of heat and sunlight to create this ozone. Again, this is a process we'll talk about in a subsequent video. Ozone here is a secondary pollutant. What are the consequences? As always, respiratory problems, plant damage. The chlorophyll doesn't act the way that it should. It may even break up the chlorophyll. Don't quote me on that. You can stick to plant damage, reduce primary productivity, and then it's also a greenhouse gas. The stuff that we talk about with the greenhouse effect, that also happens in the troposphere, and we will get to that. Okay, sulfur dioxide is SO2. The structure of it, I don't think is important. Just be kind of aware that's what it looks like. Again, respiratory irritant. Whenever you hear affects plant tissue, that means it reduces primary productivity. If you have a reduction in primary productivity, it also means that you are going to lower populations in a particular ecosystem because you have less plants to eat and less energy to move up the trophic food chain. Okay, carbon monoxide, CO. Notice that we do not, although CO2 here is listed, it is not a criteria pollutant. It is considered an air pollutant, kind of, because we also produce it as part of cellular respiration. But absolutely, carbon monoxide is a problem. Remember, that's through incomplete combustion. Why is it a problem? Because it binds with red blood cells, preventing them from uptaking oxygen, which means that even when you are removed from the source of carbon monoxide, it takes time for you to throw off its effects. That's why people who have carbon monoxide poisoning need oxygen therapy for a while. It's also one of the reasons why children and pets are oftentimes killed by carbon monoxide poisoning where adults are not, because remember, the dose makes the poison. If you only have 10 liters of carbon monoxide in an area, that is going to be a higher concentration in the body of a child than it is in an adult because there's less kid. Their lungs are, it's not that their lungs are underdeveloped or whatever, it is simply a matter of concentration. These are all potential areas for incomplete combustion to take place. Okay, again, CO2 is not a criteria pollutant, but we will talk about why it is a problem, and it's right here. It's because it's a greenhouse gas, and again, we will, although that is a part of Unit 9, we still will talk about it as a part of this unit so that you understand why that's a problem. Okay, here is the greenhouse effect. I expect for you to know how this works. Sun shines. Most radiation is absorbed by the earth and warms it. Some of the radiation is reflected by the earth and the atmosphere. We're going to talk about what reflects the earth's, what on the earth reflects the sun's light. This is the key right here. Some of the infrared radiation passes through the atmosphere. Some is absorbed and re-emitted in all directions by greenhouse gas molecules. It is not that it holds heat in as much as it is it absorbs the sun's light and then re-emits it as heat. You're familiar with the greenhouse gas if you've ever gotten into a car in July. Your windshield acts like the atmosphere. It allows the sunlight in, and then that is absorbed and re-emitted by the air in your car, which is why it gets hot. This circled part right here is the whole reason why Earth has life on it and nobody else does in our solar system, even planets with an atmosphere. It is that re-emission of heat, some of which goes back towards the Earth, that keeps our Earth at a relatively constant temperature and makes life here possible. This is a natural process. As with all things environmental science, it is the magnitude of this process that is the problem. The more greenhouse gases you have, and this occurs in the troposphere, the more heat you have re-emitted back to the Earth, which means we are starting to get warmer than processes on Earth can handle. All right, here is that reflectivity that we were talking about before. It's linked to a word called albedo. Albedo is the reflectivity of a surface. Some things like ice have a high albedo. Some things like, believe it or not, water have a lower albedo. Water can be dark. And then also you have to think that things like vegetation and dark earth have the lowest albedo of all. Although dark water, it appears, is got an even lower albedo. You will not be asked to rank these things. Just realize ice, high albedo, bare water in the ocean, and dark soil, not so much. Be aware of what the main greenhouse gases are: carbon dioxide, methane, nitrous oxide, which is N2O. Also, chlorofluorocarbons, and even water vapor. The reason water vapor is not an issue is when water vapor builds up to a certain extent, it rains. The problem with all of this stuff is it can continue to build up and make us sweaty. Notice that CFCs chew up ozone in the stratosphere, and then it's a greenhouse gas in the troposphere. It's bad news. Why is it that carbon dioxide is considered to be the worst greenhouse gas, even though it doesn't have a very high greenhouse factor? Just because there's so much of it. We've been burning so much fossil fuel and releasing carbon that's normally stored away in a long-term sink that we are contributing to climate change that way. Lead and other materials. We talked about lead extensively. Do realize that mercury, while it's largely in coal, it's also a problem in oil. Please go back and review what bioaccumulation and biomagnification is and why that is a problem for apex predators. Both of these are toxic to the central nervous system of living organisms. Why your nervous system is usually covered, the nerves are covered with sheaths of fatty tissue. And once it gets into fatty tissue, it just stays there. All right, particulate matter. I've talked about this before in other videos. Do realize that there are a lot of natural sources for this, but like so many other things, we have created more of it ourselves. Do also realize as being bad, as well as being bad for the respiratory system, it can also block sunlight and prevent photosynthesis if it's heavy enough. Some people point to this as well. Isn't this a good thing because it reduces climate change? But then also notice it reduces photosynthesis, so yeah, no, not so much. Be aware of what particulate sizes are a problem. Are you going to be asked if something is a certain size of the width of the human hair? No. It's important for you to know that anything, the reason we're obsessed with PM10 and PM2.5 is anything larger than that, our nose and throat and the cilia and mucus there can filter it out. These guys make it past our defenses and can get lodged in those little alveoli sacs in our lungs, causing irritation there. And remember, irritated sacs do not allow blood flow to uptake oxygen. And they can also become scarred and permanently reduce lung function. Other major pollutants that are not considered to be criteria air pollutants but are a problem are things like volatile organic compounds. You need to know that there are natural sources of these, things like eucalyptus, and then also benzene, toluene, and formaldehyde. Side note, these things are also cancer-causing agents, we are pretty sure. Yes, that formaldehyde, the stuff we preserve dead bodies in, formaldehyde also happens to be a main component in dry cleaning, everything from dry cleaning fluid to nail products. These are all different types of Vox. Really, basically, if something has an odor, it probably is a volatile organic compound. So even perfumes are volatile organic compounds. Again, dose makes the poison. Enjoy the smell of this stuff. Just, open up your house on a regular basis. I think we've talked about mercury to death. Understand how mercury is in our environment, largely from the burning of coal, but also mercury is a byproduct of some industrial processes, and there are companies that will dump it directly into the water. I do need to talk to you guys about the form of mercury that is a problem. Okay, making a note to myself. That is an issue. Okay, we've talked about carbon dioxide. Do realize that we have been monitoring its concentration in our atmosphere since the 1880s, and yeah, we're making more of it for sure. Know the difference between a primary and a secondary pollutant. A primary pollutant is something that is manufactured, usually comes out of a pipe. You can point. It's like a point source pollution. There it is. It's been made. Secondary pollutant is once a primary pollutant is out in the atmosphere, it reacts with something else, oftentimes water vapor, to become something else. These are a list of most common secondary pollutants. We're not going to really talk about H2O2 very much. It's hydrogen peroxide. Hydrogen peroxide decomposes pretty readily into oxygen and water in the presence of sunlight, so it's not something we're going to talk about. All right, so that is the end of this particular unit video, or excuse me, this topics